Hello everyone. Good morning, good afternoon, and good evening. Welcome you all to yet another session on the automotive technology. And this session is a continuation part of the last session that was the hybrid vehicle technology concepts. In the last session, we covered the fundamentals of hybrid vehicle, why the hybrid vehicles invented, what are the different hybrid drivetrains, series parallel hybrid configurations. We also seen the types of hybrid vehicles mild hybrid, micro hybrid, and strong hybrid more in detail. So without any delay, let me walk you through the topic which we will be talking today. Now this is a time for you to understand how energy management is done in the hybrid vehicle. Today we will discuss how exactly is the energy management works. For that, it is very important to understand what are the different components plays a very important role, or I would say what are the different issues are the part of hybrid vehicle. Then I will take you through the different modes of energy management like hybrid mode, energy mode, and EV mode. So let's start for the today's session. What are the different hybrid vehicle components or what are the different ECUs which are plays very important role in the hybrid vehicle? First is the engine management system. This is a very important ECU which controls the engine. Then another ECU that is battery management system, which controls the entire battery pack, which monitors as well as controls. Third, very important component is a traction inverter or a traction motor. And the traction motor. So traction inverter controls the traction motor in the different speed, different torque, the way we control it. The next and very important that is the auxiliary inverter. This auxiliary inverter controls the auxiliary motor and this motor provides the power to the oil pump, the power steering pump, as well as if your vehicle is configured with the pneumatic system, then this auxiliary motor helps to fill the air tank. Next, a very important component is DC-DC converter, which takes the high voltage and converts to the operating voltage that is low voltage, either the 12 voltage or 24 volt, which are required to charge the LV battery. Distribution unit, or sometimes it is called power distribution unit as well as the junction box, which as a name indicates, it distributes the power, takes from the battery and distribute to the other different major components in a hybrid vehicle. Coolant systems are all very important. If your system works on the high power rating, then you need a liquid cooling. And if your system is less power, then probably the air cooling system also works. For the liquid cooling systems, usually we use water plus glycol, and benefits of using the 50% of the water and 50% of glycol mixture as a coolant. The benefits of using glycol is its a natural property because its temperature always remains low, and as well as once we add into the water, it increases the boiling point of the water. Last and very important component of the hybrid vehicle is a hybrid vehicle controller. It is a brain of the entire hybrid vehicle, which controls the entire operations as well as manages the energy or manages the control strategy of entire vehicle. So these are the very important components, and let's see one by one more in detail. So we have seen in the last session, this is how the hybrid vehicle works. Here is the high voltage battery. If battery provides the power to the vehicle, then it's a EV mode. If the power is fed from the engine through the generator, through the AC-DC converter, and through this all to the wheel, through the traction motor, then this is called a series configuration. If the power is provided by engine as well as at the same time from the battery, then this configuration called parallel hybrid. And if this parallel hybrid configuration as well as series hybrid configuration works together, then that configuration is called series parallel hybrid configuration. This is how the hybrid vehicle components and the major components and the hybrid vehicle looks like and works. Going to the component, when we talk about the engine management system, this is the engine management system ECU. It takes a lot of data from the different sensor, manifold pressure, throttle position, camshaft position, crankshaft position, everything. It takes the input over a CAN, or sometimes it takes a direct hardwired connection from the sensors. It controls the engine operations. So it controls the running of the engine by monitoring the engine speed, load, and temperature. It also provides the ignition spark at the right time for the prevailing conditions and metering the fuel to the engine in the precise amount required. Everything, all the operation related to engine is controlled by the engine management system. And this engine management system, ECU, plays a very important role when it comes to management of the energy in the hybrid vehicle. This EMS communicate to the other ECUs over a CAN. The next very important component is a BMS. BMS is connected to the battery, and this is connected to the hard wires. It takes the module voltage, cell voltage, it takes the thermal conditions, everything through the wire to the BMS. What is the function of the BMS? What is the role of BMS? The task of the battery management system is to ensure the optimal use of residual energy present in the battery. In order to avoid loading of the batteries, BMS system protects the batteries from the deep discharge and overvoltage, which are results of extreme fast charge and extreme high discharge current. So it also gives all the information of what is going inside the pack. Individual cell level, it monitors the state of health, as well as entire pack level, it calculates the state of health, state of charge, everything calculation done by the BMS. It monitors individual cell with respect to the thermal behavior, cell temperature, cell voltage, and everything. That role is done by the BMS. And again, this BMS plays very important role in the energy management of the hybrid vehicle. It provides all information over a CAN to other ECUs and communicate to the hybrid vehicle control over a CAN, which are required to manage the energy during the vehicle operations. The next component of a hybrid vehicle is a traction inverter. When I say the traction inverter, as name indicate, the inverter which are used to propel the vehicle in terms of providing the traction power, that inverter is called a traction inverter. So traction inverter feeds or controls the traction motor. How it controls the traction motor? Whatever the speed or the torque required or commanded by the hybrid controller, accordingly it feeds currents to run the motor into the specific torque or the specific speed mode. Accordingly, it controls this traction motor, and the traction motor is connected to the shaft to propel the vehicle. This is again a very important component in the hybrid vehicle. Next component is auxiliary inverter. Now this auxiliary inverter sometimes being used in the vehicle or sometimes not used. But when it comes to the commercial vehicle, buses and trucks, it is used actually. When I say auxiliary inverter, this is again an inverter which takes the power from the battery or from the engine connected to the distribution unit. It takes that power and controls the motor. This is the role of the auxiliary inverter. But when I say auxiliary inverter, it actually feeds or controls this motor, and this motor is basically used to pump the electric steering pump and used to deliver the electric steering function. It also connected to this air tank reservoir through the compressor. So it runs shaft of the compressor and fill this air tank if your system is works on the pneumatic system. So earlier we have seen the traction inverter, and I explained the traction inverter plays an essential role in determining the vehicle's performance and efficiency. It regulates the motor speed and torque, facilitates the regenerative braking to charge the battery and ensure the optimal power delivery. Same way, this auxiliary inverter also do the regulates of the motor speed and the torque, but it does not contribute to the regenerative braking because it is not connected to the shaft. It is connected to this electric oil pump, or it is connected to electric pump, or it is connected to the this air compressor. So this is as this inverter is used to power off a reservoir and the power steering pump. This is the use of this auxiliary inverter, and this also contribute for the energy management because once this air tank is full, let's say 10 bar or 8 bar is the cutoff pressure for the air tank, then we need to turn this off. And if there is no need, engine is idling or the vehicle is not running, at that time also we no need to provide any power to this electric pump. So that way we can optimally use the power from the source instead of wasting the power. And that everything is done by hybrid controller. It disconnect the shaft from the air tank as well as disconnect the shaft from this power steering pump. Next, a very important component of the hybrid vehicle is a DC-DC converter. As the name indicates, DC-DC converter, it takes the power high voltage DC. When I say high voltage, the definition for the high voltage is not in terms of the figure or the values. Like if I say 48 volt, it may be the high voltage. If I say 350 volt or 700 volt, it may be the high voltage. When I say high voltage, means the voltage which are required to propel the vehicle. That voltage is high voltage basically. And this DC-DC converter convert the high voltage to the low voltage and provides the power or the current to charge the battery, LV battery. When I say LV battery, means it's a 12 voltage battery or the 24 voltage battery based on the vehicle configuration. Usually in the passenger car, we use this 12 volt battery, and in the commercial vehicle, we use the 24 volt battery. If this battery is discharged, then the DC-DC come into picture. It takes the power and it charge the battery, this battery. Now, what is the role of this battery? When you enter into vehicle and you put the vehicle into ignition mode or in the before putting to the crank mode, all ECUs, this DC-DC converter, BMS, hybrid controller, EMS, traction controller, or any ECUs which are in the vehicle, it needs the power. That power they need at the 12 volt power, as well as sometimes some sensors need the 5 volt power. That power is provided by this LV battery, because until and unless you are in full operational mode, you cannot use your high voltage battery. When you turn up your vehicle, shut down your vehicle, this high voltage battery get disconnected from the distribution unit. So it doesn't power because this high voltage is dangerous to the human being or um, for the human life. So it is usually disconnected. But when you enter into the vehicle, it takes some time because precharging is required to stable or reach to the high voltage from the zero voltage. During that, how the BMS will operate? Definitely the BMS need low voltage power, low voltage for its operation, and that voltage is provided by this LU battery. So during a runtime, either you can charge this LU battery with the help of alternator, or to reduce the price, you can reduce um, I mean you can um, avoid the usage of the alternator and directly use this DC-DC converter and take the power high voltage and convert back to the low voltage and charge this LV battery. This is the role of this DC-DC converter, and sometime for the sensors you may need 5 voltage, so another small DC-DC converter may be used. Okay, so DC-DC converter is again very important component of the hybrid vehicle. And the last and very not last, but it's a second last and a very important um, component, that is a power distribution unit. Sometimes it is called as a distribution unit, or sometimes it is called a junction box. So here it is located. It takes the power from a high voltage battery as well as power from the charging system as well. If you are using a standalone charger, that means the charging station is not on the vehicle, then you also takes that voltage connected here. So your charging gun, that if it is GBT or based on any standard, that power comes here actually, and from this distribution unit the power get distributed. So power distribution unit delivers the power to all traction and auxiliary loads while protecting electronic component and the vehicle occupants. And it is designed to protect all inverters, DC-DC converters, all the ECUs from the surge currents. Just imagine if you connect your high voltage here suddenly, there is a possibility this inverter get damaged because of the surge current, right? Because of the pulse current at the moment, it may happen. To protect that, this distribution unit uses some capacitor and resistors, which acts as a filtering operations and which provides your damage to the other components from the other end. Um, and it protects the components from the surge currents. It enables all the connections with the all high voltage units, load supply, and in a single location in the vehicle. So as the name indicates, power distribution unit, it distributes the power, takes the power from charging system, takes the power from the high voltage battery, and then distribute accordingly. When the charging system get connected, it comes here, and from here it goes to the battery to charge. This is how it works. And even on for the onboard charging also, if you are using the AC to plug to your onboard charger, that onboard charger's output is again connected to this junction box or this power distribution unit. And from that power distribution unit, it goes for the high voltage to charge. And then the last very important component is a hybrid vehicle controller or hybrid controller. And this is the heart of the hybrid vehicle. So hybrid vehicle always communicate to all ECUs over a CAN. It takes all the information from the battery management system. What is the cell voltage, cell temperature, pack temperature, state of charge, state of health. It also takes all information from the engine management system. What is the throttle position? What is the torque developed, actual engine torque? What is the speed? Everything, all information comes to this hybrid vehicle control over a CAN, and it monitors that because it is required for the energy management. It controls the DC-DC converter as well through the CAN. It takes all the information from the EBS. What is the speed of the wheel speed? What is the brake pedal position? Everything that information comes, EBS or ABS comes to this vehicle controller, hybrid vehicle controller. It controls the auxiliary inverter whenever it is required to turn on, turn off. Accordingly, it sends the command over a CAN to this auxiliary inverter. If it is a traction management system there, it reads the out shaft speed, in shaft speed, clutch position, gear position, everything it reads over a CAN, and accordingly it controls as well. So that is purely dependent. If the traction management system takes some torque speed control values to control the torque and the speed of the output shaft, that command sent by this hybrid vehicle control over a CAN. So that is the reason this hybrid vehicle control is called the heart of the vehicle, entire hybrid vehicle. Now so far we have seen all ECUs in a uh, hybrid vehicle, different components in the hybrid vehicle. And this hybrid control is heart of the vehicle, and it controls the different or communicate to the different ECUs over a CAN. But how the energy management happen? For the energy management, I explained in my previous session, when I say hybrid energy management, when I say hybrid vehicle, there are two power sources. One is a electric motor and another is your engine. But ideally, who controls the battery? The battery management system. And who controls the engine? Engine management system. So for this both, actually hybrid controller keep monitoring them. And as well as it controls them, sends commands over a CAN. What are the different commands it sends? I'm gonna cover that. So here, hybrid controller always look for the BSFC map, which are inside the EMS, and that takes that information from the EMS over a CAN. But what is BSFC? What is BSFC? So actually, BSFC is a brake specific fuel consumption, and it is a measure of fuel efficiency. Okay, this map basically is a measure of fuel efficiency of any prime mover. And here, in our case, prime mover is an engine. So it's a measure of fuel efficiency of an engine that burns the fuel and produces the shaft power. It is typically used for this BSFC as used for comparing the efficiency of internal combustion engine with the shaft output. So brake specific fuel consumption, when I say BSFC, which is measured in the gram per kilowatt hour, is given by basically as a fuel consumption rate, how the fuel is getting consumed per how the power is produced in the watt or the kilowatt. So any engine, this EMS controls the engine. Any engine will have a different BSFC values at a different speeds and loads. For example, a reciprocating engine achieves the maximum efficiency when it intake air in the unthrottled and the engine is running near its peak torque. The BSFC is the ratio of mass fuel consumption to the brake power. It is a measure of the capability of the engine in converting the fuel to brake the power. So it is a desirable to have the lower BSFC. That means the engine uses the less fuel to produce the same amount of power. So that is very important. When I say less value BSFC, that means it is taking very less fuel that is measured in the gram and producing the same amount of power that is in the watt hour or the kilowatt hour. So lower the value, best is the fuel. Best is the fuel consumption for the engine or engine is running into most efficient zone. So this is the contour. If they don't go by the figure actually, because your engine may have the different torque speed curves or have the different torque capability, peak torque capability. As here it is written the max torque. This is a random image I have taken to just make you aware why these BSFC maps are very important, which are located inside the EMS. But this EMS, how the EMS operate into the best efficient zone, that is controlled by the hybrid controller. So either hybrid controller look for this map and accordingly it sends command to this EMS. This is the one part because there are two movers, prime movers. One is the engine and other and second is the BMS. So from the BMS also the hybrid controller needs to look for the state of the charge of the battery. Is it fully charged or sufficiently charged or it is discharged almost or almost fully discharged or need a charge or it is a charging state. That is very important. And that information goes over a CAN to this hybrid controller. So during the energy management, hybrid controller not only monitor this BMS and EMS, it monitors other component as well. But we are not going more in detail at the micro level, but very high level, it looks for the engine management system as well as the BMS. So now let's look for the EV mode, how the EV mode operates, and during this EV mode, how this energy management comes into picture. So when I say EV mode, that means this battery is sufficiently charged, have good amount of energy, that is either the fully charged or good amount of state of charge. When I say good amount of state of charge, it is purely dependent on the type of the battery. If you are using uh, your lead acid battery or if you are using the other type of the battery, so in that case, this state of charge getting changed. Okay, so uh, usually it is recommended to operate the battery in the range of 20% to 80%. For best usage, for the electric vehicle, it is recommended to use 20% to 80%. But for a hybrid vehicle, it is recommended to use the band of the battery to operate in 40% to 60%. Because overcharging as well as over discharging is not good for the life of the battery. Okay. So I'm not talking here the lead acid battery. I'm talking about the lithium ion battery. In the lithium ion battery, the beauty of the lithium ion battery is you can quickly charge that battery and discharge the battery. So energy of that battery is very high actually in terms of fast charge and fast discharge. You can have very high energy, but when it comes to the lead acid battery, they are the very power dense. It takes longer time to discharge lead acid batteries and takes longer time to charge. But during the vehicle operation, during the regenerative braking, we need a quick charge. In that case, we use the lead acid battery as a prime source for the traction motor. So in the EV mode, we understood that our BMS has sent the information from the battery pack that good amount of entire voltage or set of charge is available. So what happens in that case, this hybrid controller sends command to the EMS over a CAN to stop the engine. And once this EMS receives the CAN command, it turn off the engine. So it does not provide any fueling to the engine, so engine get shut down. Because we have good amount of energy here, electrical energy to propel the vehicle. At the same time, this hybrid controller sends command to close the contactor of the battery. Contactor, there are two contactors, a high positive busbar contactor and the negative busbar contactor. So here, based on the hardware configuration, if you are in your vehicle, we don't have the controls on the negative bus bar, you can directly connect the negative bus bar and keep the controls on the positive bus bar. But ideally, on the positive contactor, ideally it is good to keep the controls on the both positive contactor, positive terminal as well as the negative terminal of this BMS. Once the contactor are closed, that means this battery is connected to the junction box to the inverter. And here I'm not showing all the components, but try to understand it is connected uh, to the power distribution unit, and from the power distribution unit, inverter gets the power, right? So if the driver is pressing the throttle, that means hybrid controller sends that either from the engine or a can in the EEC1 message, what is the accelerator pedal position, or or sometimes this accelerator pedal is directly connected to the hybrid control. So it sends how much power driver is expecting. Is driver pressing the throttle aggressively or smoothly? What is the percentage? Based on that, it sends command, either the torque command or to operate this traction motor in the torque mode or the speed mode. If your vehicle is off-highway vehicle, then usually we use the speed control, and if your vehicle is a on-road vehicle, usually the torque mode is used. So accordingly, based on the vehicle configuration, the commands are sent over a CAN to the inverter, how much torque is required, and that torque and speed is mapped with the position of this throttle, and accordingly, inverter start taking the power from the battery and controls this traction motor to operate the specific speed or the specific torque, and the vehicle get propelled. And this is how the EV mode. That means here we operated our vehicle in the electric mode only. Now going to the next mode, that is the engine only mode. As I said earlier, it continuously communicates to the EMS as well as to the BMS. Now BMS has communicated that I don't have the good amount of energy, battery discharged, I need charging, I cannot provide any energy. In that case, hybrid controller sends command, already the contactor are closed, but it doesn't open. The reason, it may require to charge the battery, or during the vehicle run, it may happens the battery get charged. But now the question may come, what is the energy management? Okay, right? So that I will answer here shortly. So as soon as it sends the battery is low, it sends command to the EMS to start the engine. If engine is already shut down, and if it is already start, then it's okay, and then hybrid controller will not send any command because already engine is running. Now engine is running, that means it will control this engine, EMS will control the engine, and the power will fed to the wheel, right, to propel the vehicle. Where is the engine management? So hybrid controller sense the throttle is pressed, right? So it looks inside the this BSFC curve, and I explained earlier what is the BSFC curve is, right? So it's basically measure of the fuel efficiency of any engine that burns the fuel and produces the output of power. So it looks inside this and communicate to the EMS. Now let's say you need X amount of power, and to deliver that X amount of power, if your engine can deliver that power somewhere here, right? But your best counter is here, right? So you need to shift your engine to operate here to have the best fuel efficiency. That means you can load your engine there, right? Because here your vehicle is just taking the, let's say some around 260 Newton meter of peak torque here, but this BSFC says you can take more than that to bring your engine to the most efficient zone. That means you need to load your engine, but you don't need higher speed, right? You need to maintain that speed. Otherwise, the driver will feel discomfort that he is pressing the 40% or 50% throttle and expecting the vehicle to run at XYZ speed, and the vehicle will run fast. So in that case, you need to load your engine to operate it into the most efficient zone. To make that happen, what we do, we usually brings this BMS into picture. So how we bring that BMS? We close the contactor, already contactor are closed, then it sends the command to this inverter to operate into the regenerative mode. To operate into regenerative mode, we need to send the command of the negative torque. So as soon as it receives the negative torque, it acts as a loading on here on this shaft, as definitely it acts as a load on the engine, and the engine experiences the output shaft torque is high and it shifts toward this. That means here it start consuming the less fuel and it start operating into the best efficient zone. That means it provides the best effective energy, or it gives the best efficiency in this region. So this is how this hybrid controller, because engine doesn't understand how much I need to command this inverter, and in that case this hybrid controller reads the map, understand the speed of the vehicle, speed of the engine, and look for the total position and look for the energy required, and accordingly it splits the power from this engine as well as this BMS. So accordingly it loads that engine to charge the battery. So what happens here? So during this, the battery gets charged also, right? The power is fed to the vehicle as well as the same power is taken through this shaft by this traction motor, and motor works as a generator, and this generator power fed back to this high voltage battery, and here the battery gets charged. This is called the energy management, and this energy management done by this hybrid controller. It is purely part of the control strategy, how the control strategy is written, but this is the part of the energy management. Now let's go to the hybrid mode. When I say the hybrid mode, again this hybrid controller is monitoring this EMS, BMS, and now for the hybrid mode, your battery should have the sufficiently charged. Either it is fully charged or it should have a good amount of energy. Now when fully charged, even we can go for the electric vehicle mode. But when to go for electric mode and when to go for the hybrid mode, that is decided by this hybrid controller. And what is the rationale? Rationale is fuel efficiency. How we can save the efficiency, how we can save the fuel. And for that, we need to look for the BSFC curves, right? So in the hybrid mode, hybrid controller sends command to the EMS to start the engine, right? So as soon as it receives the command, at the same time, it sends the command to the battery to close the contactor. If already closed the contactor, if already vehicle is on, that is okay. If you are just entering into the vehicle, starting your vehicle, putting your vehicle into ignition mode and cranking, at the same time, you monitor this state of charge of the battery or the voltage, operating voltage is a good amount of, then that time it sends command for the engine as well as sends command to close the contactor to connect the high voltage to the other components, other ECUs. So it also read the throttle position. So once it reads the throttle position, with the help of the start speed control command over a CAN, it sends the engine to operate into the specific torque and specific speed. So again, it looks in this BSFC map, and according to the best efficient zone, it sends that command actually where it needs to operate, how much torque we need to pull from the engine, and what is the throttle position, what is power required from the vehicle, and at the same time, how much power we can take from the battery and how much power we can take from the engine. And if we understood we need X amount of power, and that X amount of power can be taken from Y and Z, that Y amount of power is requested with the help of this PSC1 command to the engine. And accordingly, the engine start running, and it gives the power to the vehicle as well as the battery also feeds the power through this distribution unit, through the inverter, and the vehicle get propelled. So this is a hybrid mode, but power splitting is very important, and that role is done by this hybrid controller, and that is called energy management. We need to manage the energy. We need to look for operation of the engine. So always two things are very important when we say energy management. What is the state of the charge of the battery? What is the condition of the battery? Is the battery having good amount of energy, good amount of power, to propel the vehicle, and how much fuel we can save from this BSFC map, where we can shift our engine. If we are here, our engine is operating here, can we shift the engine toward this? So that always we have to look, and that is being taken care by this hybrid controller. And this is done in the hybrid mode, looking at the BSFC, looking at this battery, um, the energy is managed, and the vehicle get propelled from the both source, this battery as well as from the engine. Now, very important, and the last point of this energy management is a regenerative braking. When I say regenerative braking, very simple. Actually, this power is taken from the braking effect. What is regenerative braking? Regenerative braking is a unique technique that is used in electric vehicle as well as hybrid vehicle to capture the energy that the vehicle has due to its motion, or in other words, it's a kinetic energy that would have been wasted when the vehicle decelerates or come to standstill while braking. So if you are braking your vehicle, that means vehicle have some kinetic energy, right? And if, or even during the downhill, if you are going on the downhill, at the same time, if you want to maintain the vehicle speed to avoid any accident, usually the driver press the throttle, brake throttle here, not accelerator pedal throttle. So during that, ultimately you are using your brake pads to control the vehicle, but you can use the traction motor. You can use the traction motor in the braking mode so that it will work as a generator and provide the power back to the battery. And here, in a short amount of time, you can charge the battery. And that is the beauty of this lithium ion battery. The lead acid battery cannot be charged for a short amount of time, but lead acid battery, the lithium ion batteries can be charged. So we use the lithium ion battery as a prime source for the prime mover in the hybrid and electric vehicle. So as soon as the brake pedal is sensed, right, hybrid controller sends command to the engine to operate in the zero torque as well as the zero speed if it is already operating, because we need a braking, right? We need braking. So in that case, what happens? Engine try to maintain the shaft speed zero, or shaft speed torque, shaft torque at a zero based on the command. And this command is purely dependent on which mode your vehicle operate. If it is a torque mode, then the torque command is zero. If it is a speed mode, then the speed command is zero. As soon as it receives this command, at the same time, the hybrid controller sends command this inverter to operate into the generative mode. To operate into the generative mode, inverter is commanded with the negative torque command over a CAN. And then as soon as it receives the command, it adds the braking effect onto the vehicle. So it takes the kinetic energy, then the shaft works as this work as a mechanical energy which are feeding to this motor. And basic principles of the motor: when the shaft rotates in the magnetic field, it generates the current as per the Fleming's rules. So it generates the current, and that currents fed to this inverter, and inverter rectified that and provide the DC voltage here. And with the help of this distribution unit, that DC voltage is fed to the high voltage battery. So this is how during the braking operation, the engine is controlled, as well as this inverter is controlled to operate to charge the battery, and that is done by this hybrid controller. So in which vehicle this regenerative braking work very effectively? A vehicle where we have EBS. In the EBS, you can have very effective usage of this control strategy to use this regenerative braking, because in electronic braking system, EBS gives all the information, what is the pedal, this brake pedal position and everything. You can get more precisely over a CAN, and that information can this hybrid controller reads, and accordingly it sends this torque command, and you can effectively manage this regenerative braking um, operation in the ABS. In ABS, it goes difficult, but if the ABS is there, still you can manage. But without EBS and ABS, it goes very difficult to put your control strategy, how much braking effect required. Because just imagine you are applying your mechanical braking. At the same time, you are applying your this command to operate this motor to work as a break or kind of braking effect, right? So in that case, what will happen if the driver is expecting the 50% braking pedal I'm saying. So if driver wanted to stop the vehicle steadily, if you are sending the command as well as your engine is adding the braking effect, in that case, your from the 50% you will experience the panic braking. To avoid that, usually this EBS and the ABS helps you to understand how much energy you can have or what the demand driver is expecting, and that everything is then calculated with the help of the load of the vehicle, how much the road downhill is there, uphill is there, that is smartly calculated by the EBS, and all information is provided over a CAN to this hybrid controller. So just keep in mind that vehicle where the EBS is fully functional, there you can effectively control your regenerative braking operation. And that's all I do have today for you. And that is enough for today. So, as I would like to know always what was valuable for you inside this session. Really, I'm making something interesting for your learning. And I really wanted to know that what is valuable for you. What was your most valuable takeaway from this session? Do you have any question, any doubts on this session? So tell me in the comment box, and definitely I look for you to be my next viewer of the week, and I'll see you in the next one. Thank you for your time. Please like, share, and subscribe to my channel. Thank you, and have a nice day ahead. Bye bye.